You might remember the very first day of the term when we were thinking about what is a structure anyway. We said that the purpose of a structure is to support loads and to redirect them safely to the ground. And so with load tracing, we trace the path of those loads from the top down through the walls safely down to the ground. I really like this idea from this architect wrote a nice book called Building Anatomy, and he points out that when you're tracing loads flow down these members of a structure kind of like water flows down through pipes. Here he's made a sketch of a deck, and notice how there are tributary widths of the decking sitting on each beam. Then the beam is sitting on the girder, and the load from the girder goes into the post, and the load from the post goes down to the ground. When we do load tracing, we think about how the weight of the roof is carried by the wall, and the weight of the roof and the wall together are carried by the floor. And the weight of the roof and the wall and the floor together are carried by the foundation. And the weight of the roof and the wall and the floor and the foundation together sit on the soil and are carried by the soil. And notice these reaction arrows. The soil pushes back with an equal and opposite reaction. When we do load tracing, we start at the top and we just add up, okay, how much weight is up here, add that to how much weight is in the next layer, add that to how much weight is in the next layer, and at each layer we draw a free body diagram of that thing. And we're going to practice that in a little bit. Well, let's look at this example from our book. This is, he says, a concrete roof sitting on a garage. So the garage has a brick wall. It's got a concrete roof. Now, you might notice that in this sketch that he made, he does not tell us how deep this building is. He tells us it's 20 feet across and it's 12 feet high. He makes no mention of how deep that is. And before we move on, let me just point out, he's telling us the weight of this concrete roof weighs 100 pounds per square foot. So each square foot of roof weighs 100 pounds. This one does, the next one weighs another 100 pounds, next one weighs 100 pounds, and so forth. Anyway, he does not tell us how deep this building is. Well, that's because when we're thinking about loads coming down a building, we don't worry about how deep it is because we can just think about what is happening on each 1 foot of building. So this 1 foot of building is doing just the same thing as the next 1 foot of building and so forth. And we think about these weights in pounds per square foot, or sometimes pounds per square inch. So I have photoshopped our garage here and turned it into a 1 foot strip of building. All right, he tells us that this concrete roof weighs 100 pounds per square foot. And here we are, we're looking at a strip of concrete roof that's 1 foot wide and 20 feet wide, 20 feet across. How many square feet is that? Well, we've got a rectangle here that's 1 by 20. That means we must have 20 square feet. If we have 20 square feet and our roof weighs 100 pounds on every square foot, how much does this roof weigh? We have 100 times 20. We must have 2,000 pounds of roof there. And let's think about what is happening on that brick wall. we have this concrete roof sitting on top. Half of that roof is supported by one wall. Half of the roof is supported by the other wall. So we should think about how much does half the roof weigh? If the entire roof was 2,000 pounds, how much is half a roof? It must be 1,000 pounds. So each wall is going to support 1,000 pounds of roof, like that. Okay, so half the roof weighs 1,000 pounds. Now let's work our way down to the ground. This brick in this wall happens to weigh 480 pounds, given the size of the brick, and it's 1 feet wide and 12 feet high. I just figured that out. So this brick wall weighs 480 pounds. The question is, how much weight is sitting on that soil at the bottom? Well, we've got 1,000 pounds of roof up here at the top. We've got another 480 pounds of wall below it. So together, the roof and the wall add up to 1,480 pounds. That is how much weight is sitting on the soil at the bottom of the wall. And that's load tracing. We just traced it from the roof through the wall down to the ground.